Welcome back, guys and gals. We are looking at scatter plots again, but today we're going to do something a little bit different. Earlier we were talking about how do we graph them, how do we read them. Today we're going to start with them already pre-made, and eventually we'll get to the point where we'll start making them again. But for now we're going to start with them pre-made, and what we're going to do is we're going to create what's called a line of best fit. What this is the line of best fit kind of describes the overall trend of the data. What's that same basic pattern that the data seems to be following? If there is a pattern, then it means in theory we should be able to use that data and that line to start making predictions. And that's what we're going to do today. So in part one, we're going to do just very basic predictions. We're going to talk about how do we create this line and how do we use it to make some just very basic predictions, looking at the pattern that the data may show us. All right, so again, we know up front, we'll say this again, we know that most scatter plots are not functions, right? They would fail the vertical line test. So for example, I've got a set of data here. What it is, and I apologize for the glare there, but what we've got is a husband's age, and then we looked at the husband's wife and what their age was. All right, so for example, this data point down here by itself, the husband looks like he's just about 20 years of age, and then his wife was somewhere between 15 to 20 years of age, so very young couple in that case. Or if we look up here at this top point, the husband in this case was a little past 70 years of age, and his wife looks like about equally much past 70 years of age. So what we're going to do is, obviously, vertical line test, failing, look at all those points that fall in line. What we're going to do is we're going to use what we know about functions to help us make a better understanding of what this data is, what it's saying. Let me show you how we draw the line. I'm going to use this post-it note here to kind of get an idea of where does the data seem to be going. Because notice, the data does seem to want to fall in a specific line. Obviously, not all the data would fall on the same line, but they do seem to be following a basic trend. So I'm going to turn this on edge to help us see it a little bit better. And here's what we don't want to do. We don't want our line of fit to be too far down. Notice in this case, my line would be very low. Right? Also don't want it up here, right, where it would be too high. Certainly don't want it like that. That doesn't seem to be describing the data very well at all. So what I'm going to try to do is to draw the line in such a way that it seems to divide the data in half, okay, that all points are as close to that line as they can be. And there's lots of different ways to do this. Computer programs can help you do it. There is a set mathematical process to do it. We're not going to follow those because those get very involved. What we're going to do is sort of an eyeball. We're going to get just kind of a loosey-goosey way of getting it done just to see what we can do. So here's how I recommend you do it. So how to draw your line of best fit. Step one, draw an oval. All right, here's what I mean by that. Very lightly, and I'm going to use a pencil here. I don't use it often, but I will. Very lightly, we're going to draw an oval around our data. Now here's what we don't want to do. Okay, no. We also don't want to do this. I saw a student one year doing like this, trying to trace around it. No, we're not doing that. Right? What we want is an oval that can get as tight as it can without going around each and every little data point. Right? So again, if I were to draw an oval around this, I might draw it, I don't know, something like that. Right? Notice I didn't spend a whole lot of time drawing that oval. I said, well, how could I draw it in such a way that I can encompass everything, get as close as I can without doing something silly like cutting a point off, that kind of thing. Next, I'm going to try to cut this oval in half. So I'm going to grab my straight edge. I'm going to try to line it up here, and I'm going to draw it in. Here we go. Something like that. If you can hear my cat in the background, she's talking to me. Let's see here. Here we go. Kind of make that line. And again, just like we've done our linear functions before, we want to fill the page. So don't draw just a short line. We need to completely fill out the grid. And there it is. All right, we've got our line of best fit. Notice I've got some points that fell above, some points that fell below, some points that fell right on. And that seems to be the basic line that these points seem to be following around. So I'm going to go back now and erase my oval. We don't need it anymore. And there's one way to draw the line of best fit. Now, you might ask, Mr. Lamar, if I draw that oval and then step two, cut it in half, isn't it possible that you draw one line and I draw a completely different line? And the answer to that question is a very simple one. Yes, it's entirely possible. The way we're going to do this, there could be more than one line drawn, but all of our lines should be along the same basic method, that same basic pattern. Now, obviously, if you drew your line up here along this edge, you're wrong, right? It's too high. All of the data falls below, right? If you drew your line here, all right, well, it's too low, right? All your data is now above. But it's entirely possible that we could have subtle variations of this sort of in between, this Goldilocks line, if you will. And that's fine. So once you get your line in, what do we notice about it? Right? Well, one thing I noticed, not only do all the data points seem to want to fall along it, I also notice where I've got gaps, right? We've got two clusters here. We got one group here and a looser group here, but I notice I've got a gap. So this is where predictions can come in. I can make predictions. Notice in this case, this particular study, we have no one, husband-wise, between the ages of 40 and 50. We have no data for that age group. So what I could do is I could use this line to help me make a prediction. Now notice, if I were to say, pick a person at say 45 years of age, we grab a husband who's 45 years old, how old is your wife? We could try to make that prediction. If we do that, notice if I were to draw that data point, say right here on my line. Cool. That's called interpolation, right? Making a prediction within the data set. In other words, I've got data points above it, I've got data points below it, it's in the set. So in this case, if I were to make a prediction about, say, a husband of roughly 45 years of age, I come up, I go over, I could say that his wife, odds are, would be just a little bit over 40 years of age. So maybe she's 41, 42, maybe 40, we don't know. But based on our graph, it would appear that that would be the age range. Now, obviously, we've got some points that are above the line. So maybe if the husband's 45, the wife will be 45. Of course, notice we've also got some data points below. So if the husband's 45, well, maybe the wife's only 35, right? If I have a data point there, that would seem to fit okay as well. So we could produce a range. We could say, well, if the husband's 45, we would think that the wife could be anywhere from maybe 45, 46, all the way down to maybe 34, 35, somewhere in there, and still be following that same pattern that we see. I also noticed that there are data points completely outside. For example, I don't know of anything about a husband who is 80 years of age, right? In that case, we call it extrapolation. In this case, making a prediction outside the data set. Notice if I tried to predict an 80-year-old in this case, so let's try that real quick. If my individual I'm looking at, he is 80 years of age, let's go up here to our line, kind of drawn an imaginary data point. I would guess that if the husband is 80 years old, that his wife would be somewhere around 75. So between the ages of 70 and 80, cool, I would predict that's what her age would be. That is extrapolation. Notice I don't have any data sets above it. So I really don't have any more data to go on. At least here I've got data above and below to kind of give me an idea. Up here though, I have nothing to go on except my line. Let's try it in the other direction in this case. What if I'm looking for, say, a gentleman who's married, who's 15 years old? Well, notice I don't have any data for that. I also don't have any data for someone who's, say, only 10 years of age. And that's where I want to talk to you about. A warning about mathematical models. Sometimes, if I can get my pencil to write, sometimes they don't make sense or are just plain wrong. Here's what I mean by that. What we are creating with this line is a mathematical model. Right? We are trying to take a very abstract mental piece of imagery here, this line, and use it to in some way predict a husband's age and how that relates to his wife's. Does it work? Well, sort of. I mean, if this data is accurate, then I could predict, say, a 30-year-old husband to have a wife whose age ranges anywhere from maybe 20 years of age to up as maybe as high as 35 or 40 years of age. and still guess most people correct. However, models break down. For example, if I get to 80 years of age, well, you know what? The reason why we may not have any data in this particular case is maybe we found a husband who's 80, but maybe his wife is no longer living. Or maybe we just simply didn't have anybody in that age range. On the other end of things, the reason why we didn't find any husbands 10 years old is because people don't get married at the age of 10. So it's amazing that we even found somebody as young as we did, but there's really no way we're going to get a 10-year-old to say, hey, buddy, how old's your wife? That's not happening. But notice our model seems to want to predict that. Hey, at 10 years of age, their wife is somewhere between 8 and 10. Well, that doesn't make sense. So again, be careful. Just because it models out and we can see a pattern doesn't mean the pattern always holds. All right? For example, I did some digging. I found the price of a particular binder, and I went to multiple sites and tried to find what the price was. And at the same time, I tried to see how many did they sell. And in some cases, I had to ask the store, about how many of these are you selling a week? We got our data. All right, take a look. If I wanted to draw a line of best fit for this data, first of all, I'm going to be kind of hard pressed. Notice that our data doesn't fall in line. It's nonlinear. So for me, for example, let's say I'm going to draw my oval. That's step one. Let's say I draw my oval something like this. I know I left that data point out, but it'll be okay. All right, let's try to cut it in half. All right, cut my oval in half. I don't know, maybe something like this. Draw that in nice and dark so we can see it. So there's my mathematical model. I'm going to predict how many binders a store can sell based on that line, based on that mathematical model. Well, let's take a look. Based on my model, if a store sells them for $4 a piece, they should sell over 100 a week. Well, notice the actual data shows me that if they're selling the binders for $6 a piece, they could be selling anywhere from, say, 50 to as high as, if we're talking $8, maybe 65, 70 binders a week. Well, the model doesn't seem to work. Notice how high up this line is compared to the actual data. Contrary-wise, let's look over here. Suppose they price the binder at 14. Well, according to my model, it looks like they should be selling a little bit under 40 binders a week. The actual data tells me it's actually 50 pushing 60 a week. So again, we've got to be careful. Mathematical models can only take us so far. Sometimes they don't make sense. Like up here, a 10-year-old husband doesn't make sense. And sometimes they are just plain wrong. In this case, there's no way that I'm going to sell that binder for $6 and ultimately sell 80 a week. The data just doesn't support that. So just because we can draw a line of best fit, number one, doesn't mean we should. In this case, a curve might make more sense. And second of all, just because we can draw the line doesn't mean that the data points that it's going to provide us are any way accurate. All right. So let's keep trying this, see what we can do. So on the second page, what I want to try is you to draw the line of best fit and then make a few predictions based on your line. All right. So what I want you to do, pause the video, get a practice drawing your line. Notice in this case, it's definitely linear, definitely positive. We definitely have an outlier, so I'll be curious to see how you treat that. In this case, I looked at the age of individual students and the daily study time that they spent in minutes. So I just asked kids of different ages, how long do you spend studying each night, and wrote that down in minutes. All right, so again, draw your line, make predictions. Here are the two questions I have for you. Again, pause the video, see what you can do. All right, you should have paused the video. Let's talk about your line and what it came up to be. So in this case, if I were going to draw my oval, one of the things that I'm going to do is I'm going to not necessarily ignore that point, because we can never just take data out, right? This roughly looks like maybe 12-year-old individual is studying way, way more than their typical aged peers. However, I don't want to put my line of best fit, say, up here, because notice that's going to completely ignore all these other data points. So when I draw my oval, and I'm going to draw it kind of like this, I'm going to go ahead and incorporate it, but I'm not going to rely on it too much, okay? So let's see if we can cut this in half. And by the way, guys, if you draw a bad line, for example, that's a bad line, terrible line. Look at all these data points that are below. no, it doesn't even begin to describe where most of these data points are falling. If you draw a bad line, that's okay. If you're using a pencil, erase the sucker and try again. So again, I'm going to try to divide this in half as best I can. Maybe something like, let's see how that looks. Well, that's okay. It's not great. I think I'm a little far over there at the bottom. Let's try one more time. Maybe something like that. Yeah, that looks much better. This side's come up a little bit high to try to incorporate that one. This side maybe a little low, but overall it'll work. It'll work. Again, we're all going to come up with slightly different lines, but our answers should all be around the same. So notice, if we're talking about the scatter plot, we definitely have a positive linear correlation. We definitely have an outlier. No real gaps or clusters to speak of. Nothing that drastically stands out. You know, for example, this situation had clusters. We had definitely got a group here, definitely have a looser group here with a serious gap in between. Here, well, not really seeing that so much. Let's make our predictions. So, how many minutes will an 18-year-old study? Well, notice we have no data on 18-year-olds, so this is extrapolation. We have nothing above it to compare to. So if I go up an 18-year-old mark here, my line would extend about here. Well, based on mine, it would think that an 18-year-old would be, I'll say about, it looks like about 80 minutes. Well, let's talk about other values that could work. For example, maybe your line puts it more at 70 minutes. Okay, would that be acceptable? Well, that point seems to pretty well follow things. Yeah, if you said 70, I'd take that answer. Let's try a bit lower. Maybe you said 60 minutes. Well, at that point, I would say it's not looking terrible, but again, most of the data is trending a little bit higher than that. So I would say 18-year-old probably higher than 60 minutes in this case. Let's try 90. Obviously, 90 is not on the graph, but we could eyeball it. Would 90 minutes work? Yeah, I think 90 still fits in that basic pattern, but I would think much above 90, not so much. So we could give a range if we wanted to. We could say anywhere from 70 to about 90 would work. Anything above or below that, not so much. All right, let's try a 14-year-old. Well, notice we actually have some data points in here for 14-year-olds. So this would be interpolation. So if we're looking at that, how many minutes would we predict for a typical 14-year-old? Well, let's go up here. Our lowest data point puts us just under 40 minutes. Our highest data point of actual data puts us at just under 60 minutes. Our model would put it at almost 60 exactly. So if I'm going just based on the model, you could say about 60 minutes. However, notice my model is above the actual data. So I would probably give a range in this case too. I would probably say anywhere from about 40-ish minutes up to about 60 would be the max. Anything beyond that, for example, if I put a point here, not exactly off pattern, but certainly well above any of the already given data points. So again, I'd be very cautious to go much higher than that. All right. Let's try it again. Last one. This time we got math grades compared to daily amount of TV time, or I guess today we could say screen time. This data is a little bit old. So again, draw the line of best fit, pause the video, draw your line, make your predictions, and then come back and we'll see what happens. All right, so take a look. We definitely have linear correlation here, so not a curve like what we saw with the price of the binder and number of units sold. Definitely non-linear, definitely a negative correlation here. With TV time, it is also negative. We're trending downward as the amount of screen time goes up, grades seem to be going down. We definitely have an outlier. If we got rid of that point, whew, seriously linear. That point is really throwing us off. Definitely an outlier, does not fit with the pattern. In terms of clusters or gaps, you might say that we've got a bit of a cluster here, but we really don't have much of a gap. So again, cluster perhaps, gaps no, outlier definitely. Again, this would not be an outlier while it is the lowest data point, for grades and the highest for screen time, with one exception. Certainly not an outlier. It seems to follow that overall trend. Now, when drawing our oval in this case, we've got some options. One option is to try to draw our oval like this. Now notice, if I take a lot of time to focus on that, that could really skew my line of best fit. Notice, if I want to try to keep it as close, I could draw something maybe like that. But notice I've got too many data points above, too many data points below. They're not as close as they could be, even though this point is trying to pull the line towards it. All right? If I go like this, then I've basically ignored that point. So what I'm going to do is I'm going to try to eyeball it about midway down that line. And then what I'm going to do is creep it upward ever so slightly, just to show that, yep, that one point does have a little bit of sway, a little bit of pull. But at the end of the day, I think that outlier is a true outlier. Again, we can't ignore it totally, but I don't have to give it a lot of credence either. All right, so let's erase our ovals that we drew. We don't need those anymore. And let's talk about predictions. And again, so long as your line is close to what I've got there, you're okay. So our first question, first prediction. If a student were to watch 6 hours of TV, so notice we don't have anybody going that far out, 6 hours a day watching TV, what grade would we expect? Well, if we go based purely on the model, purely on the line, it looks like a 6-hour individual would be somewhere between a 70 and a 65. So that's what I'm going to say. I would say around 65% on up to maybe 70. That's the grade that we would expect for that individual, somewhere in there. If we wanted to pinpoint it, maybe 67. Why not? Now, some people might say, well, wait a minute. This person watches somewhere around maybe 5.5 hours, and they're making a 95 in the class. Shouldn't that count for something? Well, maybe, but this person clearly is an outlier. You know, maybe this is a person who's repeated the class. Maybe this is a person who just, when they hear things, they automatically remember it, so they don't have to study too much. But clearly, they are not the norm. So when I'm making my prediction, I'm probably not going to give a lot of credence to that individual. Now, if I had maybe 2 or 3 data points up here, well, then, yeah, maybe we do need to push that line up a little bit and ask ourselves, what's with that cluster? Why did these people have such a high grade for such a high amount of TV time? But again, we only have the one, so we're not really going to give it too much thought. Let's try some interpolation. In this case, 80%. Well, we definitely have data for people making an 80 in the class. How many hours of TV would we expect? Well, again, this is going the opposite direction, but we can still figure it out. People with a grade of about 80 are somewhere in here, and it looks like they're somewhere between maybe 3 to 4 hours of TV. So we would expect 3 to 4 hours of TV time. Now, again, are we going to be 100% correct with these predictions? Heck no. Obviously, we've got some people that are outliers, or some people that will fall naturally above our model, and others naturally below. But that's what we're going to start doing with these lines of best fit. Is we're going to try to take these two ideas and see how closely related they are. And in this case, screen time and grades seem to have a pretty close correlation. We're going to try to use these lines to make predictions and figure out what's going on. Is there a close enough connection that we could use that model and be accurate a lot of the time? Or is it a little bit looser, like, say, age and daily study time, maybe a little bit looser, that we're going to have to give some pretty big ranges in order for our predictions to be true? All right. I look forward to seeing you all in class. Again, bring any questions or concerns, and we'll spend our time in class practicing this skill. Have a good day, folks.